All right. Welcome everyone. Welcome to another Kontur and Customer Highlights webinar. Today we have Michael Tuhig from DGT Associates. We're very pleased to have them join us. We're going to quickly introduce Michael. Go ahead and say hello.
Yep. Again, thank you, Paul and Ken, for inviting me. Mike Tuig. I'm a part of the DGT team in Boston. I'm the director for subsurface mapping. We're a small bespoke engineering survey firm in the New England area. We've been around for 26 years, and we've a very interesting area we work in. We have some very great strategic clients, and we're delighted to have an opportunity to showcase one of these projects with especially how we use the Kontur system as a part of the mapping project that we've done over the last couple of years. So I know we have any questions. We have some of our principals on board here on the call. They can answer questions as well. And I think Paul will explain some of the rules on that in the following few minutes.
Thank you. All right. Like Mike said, my name is Paul. I'm a technical sales manager for Kontur, the radar manufacturer, and we have Kent in the background as well. Kent, want to say hi?
Hi, I'm Kent Martin. I'm the Global Marketing Director and President of US Kontur US.
Perfect. All right. As Mike said, a couple of etiquette things for the Zoom webinar, just so you know where you stand. So you're all currently muted, so you can say whatever you want. We can't hear you. But you have a Q&A function, which is on the bottom of your webinar window. So feel free to ask questions. This is going to be pretty organic, dynamic kind of webinar scenario. We don't really want to do the boring kind of Q&A session at the end. So we want to do this in a kind of free flow kind of way. So go ahead and ask questions in the Q&A box. Be aware that others can see your questions and your answers, things like this. But we want to build this into the discussion, right? So keep it kind of open and free and easy, okay? So without wasting too much time, because this time's going to fly past, we're going to jump straight into the content and the discussion about this really interesting historical location where this utility project has been applied, okay? So I'm going to control the information. Mike's going to describe how this was undertaken and the interesting things that have happened throughout the past and what they found using our technology, but other technology too, right? So, okay, let's go for it. Right, let's start here. Let's talk about some history.
Yeah, so obviously, DGT is a Boston-based firm. Mike Clifford and Robert Staples, our principals, were founders of the firm back in the 90s. And we all have a history that goes back into the big dig days in Boston. For many people, they've heard about such a mega project that we had. And so a lot of us founded our own companies back then. But it's a very interesting city. We've all had 40 years as the senior people involved. And it's a very interesting city. So everything from the Boston Tea Party, I mean, obviously Paul Revere, there's other things that have happened, like there was a great fire in 1872, which destroyed the entire city. But for us, it's one of the core areas of our business and where we started. And we do an awful lot of work, but we're always amazed by the history in the city. And so it's been a big part of our work, even though we work other places. But the lessons we've learned from the Boston history translates into bringing in expertise or being very, very proficient at our services. And we hope that this project will kind of showcase not only the fantastic technology that we've been able to use from Kontur, but how we use the basic fundamental principles from mapping, which was all lessons learned from generations that are no longer with us, from all the way back at the 1800s. And so for us, we have a huge library in the city. We've continued to work, but these are really interesting projects to us, and we hope that you find it interesting today. So what we will show you is that, when we talk about the lessons learned, we look back at the late 1800s in Boston. Many people think of infrastructure and they think it's not very old. But for Boston, the Boston Gas was back in 1840. They had their first facility, second only to Baltimore. But by the late 1800s, there was a huge build out of the infrastructure in all the great American cities. And the same thing was happening in European cities. So for us, we see an awful lot of infrastructure started in the 1800s. But this is existing cross-section from the tunnel that was built in Boston in the mid-1890s. And today you can see on the top left-hand side, there's the vent shaft for what is now the Green Line Tunnel. So people that visit Boston, on that left side, you see the Freedom Trail. They go right by, and a lot of this infrastructure that was built back then is still in use today, which is amazing because a lot of it is still not mapped correctly. But the lessons learned, you can see that even though this drawing was done from an analog world, it's very precise. It's got utilities. It's got above ground infrastructure. It's got basement and buildings and foundation elements. So we look at these and say, what can we take from lessons learned from what they did in these generations and carry that forward into delivery for our clients today?
Yeah, that is this.
Yes, that's the vent shaft. And you can actually see underneath the sidewalk, there's a tomb underneath that sidewalk there. On the left-hand side. So people walk over that. We still see drawings that are done by consultants today in Boston, and they still miss some of this infrastructure. So we think it's not just about utilities. That's why it's more than underground utilities. There's a lot more down there that needs to be mapped and shown and communicated in design and construction plans.
Absolutely.
So for us, we've been around a long time. A lot of us have long exposure to the different types of locating and mapping systems. I mean, my career started in Ireland working with contractors, and back then it was very rudimentary pipe locating systems and metal detectors. But over the years, we've all been very accustomed to the pipe locating system. So I've been fortunate to be featured in some magazines, about the pipe locating systems. And of course, obviously, like in the middle photograph, there's a lot of 2D GPR systems that have entered, especially in the last 20, 25 years. But for us, any of the data, it's data mortality. If you're putting paint on the ground, we don't understand that at all. That's great for underground damage prevention. But for us, it's about surveying up the results and putting that into a digital file, the digital twin everybody talks about. So paint and flags is great, maybe if you're an excavator about to break ground. But for us, it's not about any paint on the ground. We do our communication through our digital deliveries. And that's where our background in survey really helps with our delivery and making sure they're highly accurate and reliable information. So for us, the project we're talking about is a work for strategic client that started back in 2018. We have many clients that work on a contract basis where we have a long-term contract and it's on a project-by-project basis. This is one on the larger side. This is an expansion of a network of pipe-type cable. It's a very unique high voltage, 115,000 volts. It's not your local distribution system. This is what connects power plants and substations, and in this case, networking all the substations to increase the reliability of the energy network in the Boston metro area, especially in the Cambridge, which is what you see on the right-hand side. So the client originally started this project as a exercise in trying to figure out how to connect these substations or these nodes together. Our work began as a low-level compilation, a C&D. There was a number of vendors contracted to do this type of work. But very quickly, it transitioned over to having just DGT work on this. We were the only dedicated firm that had a subsurface mapping team. And for us, we took over all the routes by probably 2019 and started compiling all of the city streets into CAD drawings. These were all 2D delivery. And the idea was to evaluate which streets were the most likely to be chosen for the final design and construction. And there's a lot of design considerations that the owner and their consultant for the planning did in the background. Some of these streets they didn't want to redo because they might have done new work in underground detention systems and beautification projects. Other may have political reasons. Other may be too costly to relocate utilities. So the entire work of picking so many streets at a low level made an awful lot of sense to do a compilation, see what you're dealing with, and then transition over when they started eliminating so many roadways and street routes to get back into final route selection. For us, the final route selection meant that you go from level C and D, low level information, to highly reliable level B. And because we had been doing so many projects and in the same time period, very similar to this type of work, we were actually looking at which type of radar system would get us through these. Because obviously Boston is like any of the great American cities. They're very busy. There's a lot of traffic. It involves a lot of planning to close lane. And many of these streets, if you only have one lane in either way, to do a lane closure is absolutely horrendous to the community and to businesses. So for us, it was made more sense to move over towards, instead of traditional locating in the middle of the city street, we wanted to look at something that would give us ability to map a street, to do it without innocuously not interrupting traffic or pedestrians. We wanted to do it very reliably and position the data. So pushing our 2D GPR system didn't make sense anymore. So moving to the Kontur system was the one we selected after testing on various other systems. The reason we picked this particular unit is because we can deploy it easily, no traffic control. We can drive anywhere from 10 to 12 miles an hour. We collect a huge amount of data, and it actually minimizes our time in the street. And as you can see from one of the videos coming up, there's no traffic control and there's no impact to the communities when we do this type of work. So thanks to people like Google, you know, we're just driving through the world without a problem. You know, it's very easy to do this. But for me, it's self-preservation. I have 40 years of doing this. Working in a city street where you're looking at a device or looking at a 2D GPR system can be very dangerous, especially with so many people distracted or drunk drivers, especially with their phones these days. So having something that drives through the street made a lot of sense to us. And then on top of that, even though the form factor was good, we wanted to do something different. And it was very fortunate for me that you know, our principals, Mike and Bob, invested in designing something that suited our application and our environment that we work in. So we designed the orange system here. That's our traditional colors. We designed it based on past lessons learned from working with systems. We wanted to protect our investment. I mean, the antenna is a very expensive antenna. So we have a skid plate underneath. We're able to set the control height with the 4 go-kart wheels, which are designed to do high-speed collection, even though we prefer to run 12, 15 miles per hour. We've got the internal GPS. We got GPS in the roof to help positioning. And then we also are able to launch the system, lift up and down, and Paul will be able to show you that video next. And this was a part of why we like this. So this video shows, so the controller, which is often one of the drivers, I do a lot of the driving on these projects, but being able to remotely launch and retrieve the system so we're only collecting when we need to do this is very important to us. That means there's more and improved safety for us. You know, we've seen in recent weeks where surveyors have been killed on the side of a highway in Florida. And so that exposure for geospatial professionals has gotten more and more in recent years. So improving our project safety, we believe that a lot more people will be collecting data from those dangerous travel lanes using systems like this. So this particular antenna is the 2.1 meter. We chose this system to minimize how many passes we do on a city street. So on this project, we actually are able to collect twice in a single lane. Once, you know, dedicated to the left side, the second time we'll dedicate it to the right side. And between 2 passes in every travel lane, we get the coverage of a complete street. And that's very, very important for us. So that means there's no gap in the data. That means the other part is that we can collect day or night. We do it in inclement weather. We have very good high visibility and always maintaining our safety. The other part is by having the positioning of the data, it's not only just giving us great information for underground utilities, but we've been able to identify, you know, the buried tram tracks, rails, anomalies, all the railroad sleepers that have been left from the old rail systems. We find voids all the time, bridge approach slabs. These are the things that normally don't show up in other people's documents. And we find that the Kontur system was the very best one for us to use for the environment we work in. The other great consideration for us was the form factor. What can we do with this? So I know, as a practitioner, we're not scientists. We're not, very smart. But at the end of the day, when you work with a system every day, you learn the pros and cons. One of the great things about this was we were able to design to have these vehicles that have a very low impact. They don't get a lot of attention, but we've actually stripped these commercial vehicles out, and we've actually designed systems to make sure all of this equipment moves into the back of this vehicle, so we're not towing trailers and having a big footprint on projects. And the takedown and setup time is minimum. We've been able to set this up in less than 30 minutes. The takedown often takes 15 to 20. And because of the way the handles and everything work, ergonomics and the health and safety, workman's comp is always a part, because we're always conscious of the health and safety of our staff. So being able to lift and put this in and out of the vehicle, travel easily, have a low footprint on projects has been very, very good for us. So this project that we're talking about was a very good application for this, because trying to get to level B on so many roadways at the single time, we wouldn't have a bandwidth to do that as a single organization. So what we did on this project, we actually contracted with a few firms that did utility locating. So these would be professional locators that are working with an RD or a Subsite or a Metrotech every single day. They're tracing out utilities, and our survey crews worked through that. So this would have been during the COVID days, actually, moving into 2021. So the benefit of having this radar system is that we minimized any time we did with our sensors and software type radar, and we moved over to collecting every area we worked in, we collected with this radar system. Now, the great benefit of that is anything that our crews missed on site, we actually have multiple data sets. So not only do we have legacy data from our files, our DGT huge library and history, but then we've got data coming in from C&D, from even other vendors that had supplied data to the firm. And then we compounded that by having our traditional locate, and then the last layer of detail that was put on there was this radar system. So by having the Kontur radar, and part of the reason why we chose the Kontur system was the ability to take those existing files, whether they were C&D or even having some of the level B information in there. We're able to XREF that in and have that GeoTIFF in the background, which really helps with the processing of data. And for us, that is a huge amount, because these city streets, when you go back and you think about the beginning of our conversation, there's utilities that were put in the ground in late 1800s. Well, those utilities don't, they exist in today. So like exactly, Paul, we talk about some of these lines, these water and gas lines. These have all been, either abandoned in place if they're small systems, and the metal didn't last. So they would have corroded away in time. The owner would have gone in and put new utilities, adjacent to these existing systems. So for many projects we look at, there's the existing facilities are the new systems. They've forgotten about the abandoned systems in place. And some of these are very problematic, because what looks like a white space on some people's drawing and maybe room for a designer to build a new line, we find that is already cluttered, and there's already other things in there. In this case, I guarantee these 8 and 10-inch pipe, they're no longer in service. We do know a lot of the bigger systems, electrical and telephone, but a big sewer and drain systems, they're definitely in place. And
hey, Mike,
yes.
Just to interrupt for a second, going back to your configuration of the van, we had a question from Matt Dragon. Can you comment on the survey wheel configuration? Is it off the van wheel? So I'm assuming he's talking about the DMI.
Yes. So we have the DMI is the Kessler unit is running off of our vehicle. So we have the 8 stud. So we have the right adapter, and that is wired in, and it goes into our geoscope, which is built inside the back of the vehicle. All of the wiring from the antenna and the GPS all goes into a dedicated place in the back of the vehicle. But that is our DMI on the wheel on each vehicle that we have. Yep.
Excellent. And just everybody, instead of raising your hand, can you just type your Q&A or your questions into the Q&A if you could?
Yeah, absolutely. This is also interesting. The build of the road, which is typically still there. It's just been overlaid in new asphalt, for instance, and you can see this in the radar data as well. That's kind of interesting too, because if you're going to excavate typically you have to put
Yes.
back what you find, right? So it's
Yep.
kind of interesting to see, especially if you put a new you install something new,
Yep.
and then you're responsible for that reinstatement. And
Correct.
maybe that reinstatement fails in X
Yeah.
number of years. That reinstatement might fail because the surrounding build is this.
Mhm.
And this may be stronger than what you put back, because you're not going to put this back necessarily, right?
No, I think all of those cobblestones, they were very typical in many cities around the US. And we
Right.
still find quite a few of them in the radar data. I don't think they ever reinstall them. I think every construction worker fills his truck and he brings them home and makes a happy
Yeah.
wife and a new planter at the house. And I
Yep.
think everybody has some cobbles that they brought home. But we do find it in the radar, and it's very interesting pattern when you see it in radar. But we do find there's still an awful lot of that there. Mhm.
There's some. If you don't follow Mike on LinkedIn, he does some very nice Monday morning posts with historical information. You should really follow him there, because some of these are, you don't get to see these kinds of images very often. So yeah, as DGT has an enormous amount of historical information, which is really interesting, because sometimes we forget about this stuff. I mean, these are gold dust, in fact. And we were
Yeah.
talking earlier, Mike was
Yes.
calling this an early mobile mapping unit, but these kinds of images are just
Yeah.
incredible, in fact.
It is not only is the quality from the 1800s of photographs, but what impresses us is the size and magnitude of these projects that were completed in a time where it was an analog world. There was no digital, uh, anything. There was nothing. I mean, you think about it, was even before steel tapes for survey. So how did you do these mega projects and bring them in on time and under budget in a time where you have no communication, no cloud-based systems, so we're always impressed by these. And for us, there is a lot of, we have a huge library ourselves, but we're very fortunate. New England has several digital locations where you can do search. So like Digital Commonwealth is a place that Mike Clifford and I always look at projects. So, and we often joke that we actually don't do any tomorrow projects. Anybody that calls us and say, I need you tomorrow, you're definitely an idiot. We don't want to go visit. We like to do our homework. We want to know and plan out what we're doing, what has been there before, what we know about the site location. And so for this is another great one, Paul. So for us, we always begin a project when we get a call. And so what do we know about the site? What kind of history do we have there? And that historical perspective helps us with the project approach, what we're going to find, how we apply the technologies that we have, whether it's doing LiDAR for the above ground instead of traditional total stations. So there's an awful lot of things we can garner from this type of historical perspective that it's very interesting, but it has an impact on our work. Actually, what you're seeing here is a part of the downtown Boston area. This would have been very, typical of the streets back in the day. The machine that you see on the right-hand side is actually a steam-powered excavator. It was called an incline machine. And today we see a proliferation of vacuum systems across the globe. Well, this was the precursor for that. These systems were using steam-powered and that hoist system to manually excavate out from underground. They dug it and put it into buckets. They mucked it out, put it into horse and carts, and they carried it away. And these systems were mobile. They set it up and took them down, and they moved them around the city. So on the MBT, or the mass transit projects that we look at for, like we saw earlier on their cross sections, the way they got the detail for the underground, it's not schematic. These were survey-based documents they made, and they went to the extent of doing this level A excavation that we know it today. They would have done it by exposing facilities and measuring it. The other part that comes up quite a bit for us is these sidewalks are actually not always a solid surface, terra firma underneath that. A lot of the buildings in the Bostons, Chicago, Philadelphia, New York had the same thing, where the building extended out to the curb line, and there was often coal delivered through chutes or even material into those buildings. So for us, looking at these streets, getting to figure out, is it a granite sidewalk that has an underground space? That kind of helps us with what we call the law of limited real estate. It means that all the utilities have to fit between the curbs and There is nothing underneath the sidewalks. So again,
Right.
very important parts for us, for our history and knowing what we're dealing
Yeah,
with.
we had those. We had those in London. Yeah,
Mhm,
we experienced those coal chutes
mhm.
were prolific. Yep. So
Yep,
yeah, the extent of the building line is not here. It's
mhm.
actually here, for instance. Yeah.
Exactly.
Yeah.
And to this day, we often have projects. I mean, we just did a project that has all of the sidewalk as an underground space, but people don't realize, because you'll have a lot of people make decisions based on dig safe or one call here. And if they say, well, there's too much paint in the street, so I'll have to, take a core hole in the sidewalk, that doesn't seem to have any utilities. Well, what they end up doing is drilling into the basements of buildings. And that's quite,
Mm.
it's not common, but it's not unheard of in the Boston area.
Hmm. Hmm.
And again, for us, the archives is everything. So not only our own archives go into the 1800s. And Mike Clifford and I have been adamant about sorting, storing, scanning, and collecting a library of information, because it's a huge head start on the project. For us, we're very fortunate that we've been doing this a very long time. So we have an extensive library. And Mike and Bob have actually purchased, I think, about 8 different firms over the years. And a part of it is not just the good business sense to acquire some of these farms, but the legacy documents is very, very interesting to us, because a lot of this documents is not retrievable anymore. You contact some of these asset owners and you just get a copy. We joke about it because they said we're in a digital world. Well, when we get a copy of a GIS, that's usually a JPEG or a PDF. That's not a
Mm.
digital world. I'm still XREFing in these documents. But what's really important to us is this is a sample on the left side of one of these documents. This is 1896, and you can see these are watercolor quality documents. But if you're connecting utilities by the surface structure doing C&D, there's no way you're going to communicate what's going on with these chambers, these siphons, and these connections underground. And you definitely would not assume that that is what you find here. So none of this ever translates into the modern GIS. So having these documents, these historical perspective that we go back to, is very, very important for us. It really fills out the picture. So technology only gets you so far, but you have to do that homework to understand what's going on underground before you deliver that project to the client.
They're unbelievable, unbelievable images. The quality of the images are outstanding, actually.
Yeah,
Absolutely
we look at
outstanding.
it, it's like Ansel Adams. Somebody took the time to go out and photograph these projects and then go and annotate the photographs.
Yep.
Ironically enough, in the digital world we live in, we often look and say, what do we know about a project? And we had one recently that was a hospital project that was only 10 years old. We failed to find any project plans for the project. And not only is there no project photographs, there's no as-built of the new utilities. So you're left wondering, are we going backwards or are we going forwards? In a digital world,
Mm.
it seems like we're becoming idiots when it comes to storing, documenting, and being able to retrieve what we've had. And so for us to be able to go in there, we look at this, these are all searchable by street names. So Mike Clifford and I will easily go in and say, what do we know about this street or the street intersection? And it's digging through these to understand. And by getting this, we often come across projects and pipes that we can see. Not only do we get to trace them out, but we actually get to visualize them in these historic pictures. And that's a very interesting perspective for us.
Where would you like to go next, Mike? Do you want to have a look at where you took the composite plans, where you XREF this information and look at it
Yeah,
superimposed in Examiner? Is that something you?
yes, I think so, because that was a key part of the success that we've had with our system. So, first of all, you always think of a radar system as being something that is just going to find utilities and you're able to plot position. But for
Mm.
us, years ago, 30 years ago, I had my own SUV farm and my vac trucks. And, I thought I was rocking it with big diesel trucks, burning diesel all day, making test holes. But for us, when we look at the radar data, not only do we get to work in the composite, we take this data in and we're starting to get a lot of vertical data points from the system. So what we have calculated, and it's a very rudimentary number, but we believe it's pretty accurate, is that every single time we get a vertical depth, a reliable depth of a utility from our radar system, it costs $1,000 if that same vertical point was achieved during vacuum excavation. Now, on this
Yeah.
project, we did thousands of vacuum holes to expose utilities, and the customer really wanted to do that. But we found that we had thousands and thousands of reliable depth information that we were able to put on there. The other thing that's interesting about Examiner is this was one of the key reasons why we chose Kontur as the person to commit our experience and learning, because there's a lot to invest here to get up to speed. But having the geotiff in the background was really important. So this is a geotiff. You can see that everything on the left side is all low level. It's all quality level D. So this was an early compilation. There wouldn't have been any QLB done at this stage. It looks on this project. But when we go through this, we get to figure out what is going on the ground. And many times the water, sewer, and drain, Boston are pretty good at that. The gas companies around the country, pretty good at their stuff. But the telecoms are atrocious. And so the telecoms keep on building out systems and they don't provide plans. So being able to, have our Kontur system to be able to export out our georeference, these scans and put them in place very easily, very quickly. Mitch Liddell was our tech, and Jeff Young was and Mike Clifford's Jr. was a part of this for us. We were able to go through very, very quickly and build up a quick picture of what's going on here. And again, this would have been done with no traffic control, no vacuum trucks, no lane closures. So it was very economical. But having that, there's the, which one? The one in that one is a very interesting one, because this is a very good, so I know the byproduct is doing the video, but it's a great way of doing a review, a Q&A. And we love to look at the system. So I think people don't realize when you look at a street, there's a pretty nice smooth surface. But when you get into looking at the data we get from Kontur, those road scars create a story for us about what we're seeing, who's done, where's the location of chambers and manholes. The other thing it gives us is when we run through these streets, if we ever make a mistake surveying up a surface structure, because the GPR system, your software Examiner, gives us a position when we pick that data, we're able to do a QA/QC on our survey, whether it's a GPS or total station make a mistake. We get to see it because it'll show up as these bright reflections. So each of these road scars is something we investigate. And not only we want to see, have we found everything, but there's also looking for those telecoms that have not provided plans that may or may not do a mark out on the street. And that's really important for us. So this is a typical of a urban arterial roadway, but you can see it's pretty congested. There's some major utilities here. And again, this would have been almost impossible because of the level of traffic to close lanes here. And we drove by this. This would have been called, Thursday morning for us. It would have been very easy and very quick to do, but very reliable information. And we would have collected the other direction on the other street. So we would have overlapping sets here. But this is a great demonstration of what you can see.
It's definitely congested. There's a lot going on. Yeah, there's a lot going on. And for those that haven't seen this kind of stuff before, this is, of course, like a helicopter or bird's eye view, technically called a time slice, but it's a combination of all of the channels in Mike's system, and created as an overall view of a three-dimensional system, to give us this very dense view of the subsurface, which enables us to see things like these manhole chambers, right? Obviously they're on the surface, but other things as well. People go, they pave over manholes, right? So that could be another issue, right?
Yes.
Where you start to see.
I'm sorry. When we're looking at this, Melchior just came up with a very interesting question exactly about this. Can you give a very rough estimate or upper and lower limit of the percentage of pipe meters that you can detect with the Kontur system compared with the 2D plans? So, I mean, how much are you actually pulling up in here, and percentage of getting things? We had an interesting discussion about all utilities in yesterday.
Yeah, and we always joke that there are several times Mike Clifford and I will see somebody request all utilities. Well, that's Jesus. That's not us. There's no way to find all utilities there's no technology today that can do that, except if you want to vacuum down and fully expose the entire project area that you're going to work in. That will get you utilities, with complete confidence. So for us, we get level B where with our traditional locates, we always find that back in the day, I have been very happy to get that information. I thought I was at 100% when I did my mapping. But what we find with the Kontur system, we're probably finding another 10 or 15, maybe 20% more information. And we're getting more reliable depth information on those systems. Specifically, we find that we see a lot of the older pipes. So you imagine the old gas and water pipes, they're all heavy metal pipes. These would have been cast iron structures with very big bell ends on them. So we find a lot of abandoned systems that would not be normally shown. Now, some people said if it's an abandoned system, I don't want to know about it. It doesn't affect us. But for us, it's very important. Our job is not to tell you what the condition assessment or, what's going on with each of these pipes or the pipe pressure. We want to tell you what the existing site condition is and all of the things you know about. And like this image, for example, you can see that the buried train tracks are still there. And you can see there's an awful lot of rail. There's a lot of new utilities. And you can see each of those excavations. So for us, we're still finding that we're probably 10 to 20% more information because of using a Kontur system. And every big and small project for us that's a locate, even a small plaza one we did recently, we still take the time to cover it with our radar, our wide array Kontur, as well as going with our 2D GPR.
Mm-hmm. Yeah, these are really nice examples, Mike. These are really, really nice. And just so that people know, on our website we built a project page which you can visit and you can take a look at this stuff and you can download the information that you're seeing today as well. So you can see some examples of that. We did a very nice customer focus page there. So if you visit our website, you can take a look at some of this stuff in more detail in your own time as well. So there's all of this is there too. So you can take a look at that.
And Mike, as you're going through this, can you give us a rough example of, just approximately how long did it take you to collect all of the data? And then how long did it take you to do the analysis of the data?
Well, it's the whole project is very complex. It's only going through the final stage of design right now. So this project started in 2018 and we're already at 2025. We've just finished 2 years of vacuum excavation the customer wanted to do. So it's very hard to say we did, say our 60 miles over 5 years. That's not really truly representative. We did, if you're looking at this is a street called Vassar Street. It's an extremely dense street. The challenge with this is there's so many, you can see right on the very bottom, it's quality level B MIT. So that would be an MIT telecom system in orange color. There would be no public information we could acquire for that system. So the current asset owner does not provide us with information. So doing our homework, again, we were very familiar with Vassar Street. We got 40 years of history. This is over a mile street. It would have been at least $100,000 to do this type of street because it's so dense, it's so congested. There's so many utilities that are public and private that are in the private way. So just doing a design ticket for 811 is not representative. To doing a mile of this type of street, which is as tough a street as you're ever going to find, would have been about 3 weeks of quality level B at your traditional crew with a pipe locator and push cart GPR. But the GPR collection would have been done in a single day. So this would have been Mitch Liddell and myself or one of the other techs driving this, getting the entire coverage curb to curb. In some areas, we're actually able to do the sidewalks because they were big enough and they had some ramps. Processing time for that very same file, it would have taken us about 2 weeks to do the entire C&D on that street, but it would have taken us probably 2 weeks to extract all the data, compress it, and go through all the historical records and put it together. So this is not really representative of a normal project, but this is very intensive project. The other part that's problematic is you can see down at the bottom, again, there's fiber optic that we have and there's communication. The problem with a lot of these, Kent, is that for years, the idiots at the telecoms decided they didn't want to put a trace wire inside in these systems. So if you're out there with an RD or a Metrotech, that thing is absolutely, you might as well go play cricket or baseball with it because you're not tracing that. And for us having a radar system that you can clearly see that trench across the street means that we know it's in there. We know that there's supposed to be permits or easements for some of these, but none of that is something that's retrievable. The radar system, when you drive over it, is agnostic. It doesn't care what you put in and what date you put it in. It's very clearly defined when we go look at this work. So you can see there's a combination of QLB. So the QLB was done at this stage, but there's other things that we find. So you can see on the north side, there's quite a lot of the services that are non-traceable. They're non-metallic line. There would have been sewer and drain QL, C, and Ds. So many times we're able to find those type of utilities as well. And these are important for us because they're not documented. Typically, you don't find any of those laterals documented. The big part for us is that this is constant street. None of this ever had traffic control. And when we did do the VAC-X with the customer, we found out our results were very reliable. We never had days where we're finding 2 or 3 pipes that was not in our files. It was literally about getting the top and bottom of ducts from excavation to put level A into our final deliverables.
Mm-hmm. And then the deliverable side of life, Mike. I think we have some examples, right, of what you did in terms of building something, right?
Yeah, we do get some customers. Even this customer has requested, 3D deliverables. They've asked for modeling of 3D data, but this project was done and started with CAD deliverables. It was all 2D. So there was no 3D until recently, until the last project we just did. Actually, that's right. If you go back one moment there for us, Paul, this is an amazing slide. So you can see, again, this is a part of Cambridge Archives on the left, and this is an underground structure. And you can see the detail that they put in back in the day. What really annoys us is the lack of detail that we see in a digital world. So we've got all kinds of systems for, imaging, photogrammetry, whether above or below ground. You've got LiDAR systems. You can do amazing things. And yet we don't do amazing things. We do very mediocre things. And you look at this and saying, why can't we do better after all the technology and everything we've learned, and now we're putting out mediocrity. Even at these cases, you'll see there's foundation elements underneath these structures. So they knew back then that we have terrible soil. So all the videos you're looking at for DGT on this project, we have Boston blue clay, and most of ours, it's reclaimed. So this would be in a much better results had we been anywhere else. But, that's the card we're dealt with. We have salt water by the ocean, and we have heavy clay, which means the data, as good as it looks to you, it could be much better if we were in a different location. And we do get better results when we travel. The other thing that's amazing is that when this was a part on the right-hand side is a slide from the city of Somerville. And if you look at the build out of big infrastructure, this was amazing graphic for us. You see how many systems were built back over the years. And then you look at what 1980 to today, in the last, we're not building much, are we? So, and it's so congested, that means that all of the things that are in there, you have to find on modern projects. There's no way you are going to run into things. It's just you better find them ahead of time. You better relocate ahead of time, do your utility coordination. And the only way to mitigate that is to have all of these tools at your disposal. So we see the future for us is that maybe not everybody's going to have the system like we have or the Kontur, but you definitely should do a peer review with these type of systems to see if you found everything that's out there today. But some of this is amazing facts that we uncovered during this project.
Hey, Mike, you just said some interesting things about the quality of the problematic soil that you're shooting through. I've answered some questions about our depth penetration, typical with their ground system. What were you actually finding in terms of how deep you were identifying targets?
Well, we were doing really good to the 5 or 6 foot mark. But it varied from street to street as you got close. So that Vassar Street, that is all reclaimed land. That is water 100. By 1900, that was a part of the marshland, and it got filled in over the years. And then the MIT campus was built on the other side, the south side of Vassar Street. But that was all reclaimed land. It was terrible soil. But because even if the soil is bad, we still get decent results because when they cut through and they backfill, a lot of times you may not see the exact utility, but you can definitely see, just like you saw on the street that we had up there, Western Ave, and looked at in the video, you can see those road scars in there. And those road scars really give you a good indication of where to go back and go hunt again that you may have missed something. We had the deepest we got was about 8 to 10 feet, but that would have been somewhere where somebody had excavated and put very good clean material back into that excavation. But again, we're in a bad area for soil conditions. So to get this kind of results was very, very impressive. And again, you can see some of these historical records are amazing. For us, you look at this, you can see how much is buried, and it's stack facilities. So in these smaller streets, they tend to always have more and more utilities. Telecoms fill the top, and then you have some of these others going deeper and deeper. So we actually did find that there were several places with our radar system, we were able to identify several layers of utilities, which is problematic if you've ever used a pipe locator that you're tracing and you keep tracing in the same place. You're always chasing, did I get a good ground? Maybe I'm grounded. Maybe the signal is running and bleeding off. But then when you find and you go back with the radar, said, I'm not an idiot. I'm actually still doing pretty good, but it's just the site conditions are challenging.
Yeah.
But to answer your earlier question, everything for us that was done on this was done in 2D in CAD until recently, but we have other projects where I had to do 3D and 3D modeling. Unfortunately, this is the PDF version, but this is an interesting story here as well, Paul, because we look at the history of Boston and say what lessons as geospatial professionals, surveyors, and even though we have engineers and we make fun of them in our office, but there's some fantastic lessons for all of us, and it's a big joke with us because it all starts with having a great existing condition survey for all the engineers. And you look at that drawing on the left. This is the corner of Tremont and Boylston Street, downtown Boston. It began in 1893 with the project. 1894 they started making thousands of existing condition drawings, and this is a color drawing. It's done to scale, and we've actually surveyed this intersection, and those utility structures are still in the same place today. It was very highly accurate, it was reliable, and many of the pipes are still there today. But it gives you the planimetrics, so you see the existing buildings, which are still the same buildings today. You can see the buried tram tracks, which is why they were building the subway in the first place, because it was so congested. But all of these utilities were still there, and we modeled this a number of years ago. And the model you see on the right, that's 1800s congestion. So when you get a designer looking for an easy route through a city, I don't care where in the world you are these days, it's pretty congested down there. So how do you unravel all of that history? You need the tools like Kontur and that to work with your other systems to be able to get this reliability. And this one, of course, we use LiDAR and that as well for the tunnel and for the part above ground. But it's very interesting. The other part of this is that it's not only a great lesson for us about how to map utilities properly, it's color coding existing plans, that's a given. But this intersection in 1897, I think it was March of 1897, there was a contractor damaged a gas line, and that gas line exploded. It's the first documented third-party contractor damage that claimed lives, and I believe about 9 people died because of a contractor breaking this. But again, there's an awful lot of history here, but those history translates into educating us in our generation.
Yeah. I'm taking it that this wasn't one of the routes chosen.
No,
they can't really go.
Yeah,
they can't go deeper either, right? So I mean.
Well, yeah, so this is not a part of the route, but this is one of the samples we always show in our work. But we had several subway crossings on our project. It would have been, this is obviously the green line, if anybody knows Boston, but we crossed the red line tunnel. So we were actually profiling the roof of the tunnel and then further investigation with back trucks to get the exact depths for profiling and depth of cover for the new pipes and keeping the separation they were looking for.
As a contour question to that, how accurate was the depths that you saw in the GPR information to when you actually excavated?
Well, on the tunnel itself, it wasn't spectacular, but we believe that was because of the soil and the number of utility crossings. But we've been able to see several places where within 1 to 2 inches or 25 to 50 mil and getting very reliable depth information that we've already, and we plot that information even on 2D. We do put in the record depth of anticipated depth for some utilities. Now, we still have the caveat that, I know some places geophysics depth is something reliable. We still hold by the ASCE standards. It's only an indicated depth. It's not a final survey grade answer. So we still demand that you do VAC-X at any place you're going to have a high conflict. So that's why there was so much VAC-X done on the project as well. But very reliable depths from our Kontur system.
Any final thoughts on the project, Mike? Oh, there's that. This is fantastic. I've never
Yes,
seen one
that's
of
the
these before.
incline. Yes.
I've never seen one
So,
of these before.
yeah,
These are
my
great.
kids thought that was me on the right-hand side, by the way. That's where I was getting my lessons learned. So,
And Pat, you've been very patient with your hand raise. Can you just type in your question into the Q&A box if you could? And while we're taking a quick pause, we had an interesting question from Vignesh about pavement thickness identification. What's the max data collection and processing to be achieved in an 8-hour shift? Now, that's going to be our air coupled, which is not, it's more the pavement and bridge applications than the ground coupled, which is really the utility mapping applications. But maybe, Paul, you can just give a really quick answer to that.
In 8 hours, well, I mean, it can travel at road speed. So yeah, whatever the maximum road speed is, you can travel at. So the answer would be, if you're at the 70-mile-an-hour road speed, then you can travel 70 miles in an hour times 8. So you can capture a lot of data with that system. So yeah, of course depends on a little bit the amount of lanes. So consider your uh, size of the project, how many lanes you have, whether you want to do some overlapping. So take the footprint of the antenna that you're using, and then consider the size of your job. And the road speed. So you can absolutely collect data at posted road speed, no problem at all for pavement thicknesses. Yeah.
And processing wise, you might want to mention some of our augmented tools.
Yeah, so processing wise, we have very nice processing packages all within Examiner, as you've seen earlier. This year we've launched a new tool called Kontur Orbit, which features a tool called Analyze, which is based upon the user creating a reference model. So you only really need to process a section of the project and then run the model on the remaining part of the project. And Examiner and Contour Analyze will take care of the rest of the mapping. So subsurface mapping is now something that is almost taken care of for you. You just need to QC the results. So really, we're kind of pushing forward now to the point where a project for pavement thickness and mapping is something that you really only do a very small percentage of. Let software take care of the rest, and then do some QC. Okay, so yeah, it's changing quite rapidly. In fact, this type of data analysis and assessment. Okay, yeah, so you'll see a lot more of that this year. Yeah, absolutely. Yeah.
That one came through and was an interesting question. So we can give
Absolutely.
Mike a quarter second to get his voice back after talking
absolutely.
for so long.
No.
Yeah, go ahead and summarize, Mike, and we'll finish off. But thank you for joining us. It's been an education to see something on such a big scale, and the historic element is absolutely vital. Absolutely vital.
Yeah, we're delighted. We couldn't be happier with our investment. I mean, back in the day, I invested heavily with vac trucks, and you can see now these are become very commonplace. I mean, this is one of the great vendors that worked on the project with us, APC, and they're dedicated vac people. So we think that the industry may change in the future. Instead of having SUE firms all have vac trucks, I think it makes more sense for us to invest in technology and leave firms that have a completely different configuration or makeup, like these excavation companies, do that vac X work for us. For us, we don't want to deal with traffic management. We don't want to deal with all this excavation permitting and having this high impact. And as geospatial people, we try to minimize that impact, all the way from not painting the surface. That's not what we do. We don't do it like DigSafe. And so having that low impact, we think, is very valuable to our clients. Having the tools, we think what's going to happen in the future is that more and more firms will follow in our path and invest in systems like the Kontur to be able to extract more data more quickly and have a more thorough understanding of the underground. And we think that is going to be the future, because as you go in from a 2D world to the 3D world, it does have a significant impact on how much data in the 3D environment you're going to be able to capture. So we think it's really important, and we're never going to stop collecting on our projects. All projects work with our Kontur system, even if it's a small project. So we think it's a good service for our client, and I think it's a really good workflow. But we really appreciate the time you guys, not only today on the webinar, but to feature us on your website. And it's a valuable tool. We think that AI, as we go through, will change us in the next couple of years. We're already seeing some people being able to go back and look at the same data we've collected, because it's already, geopositioned, and be able to re-examine that with AI and say there's even more to be garnered. I've only been doing it 40 years. Doesn't mean I'm very good at it, but as AI, may be able to go back in there and say there's still more data that you haven't got the first time. And reprocess it. And we think that's pretty exciting, that AI will do more for us in the near future.
We agree. We agree with you, Mike.
And that actually brings up an interesting question that Matt had put out, which is, are we currently using AI and use in the future? Which I think I would call, and Paul, correct me if I'm wrong, I would call most of our tools an augmentation as opposed to AI at the moment. Is that more probably accurate?
I mean, it is AI. I guess we could blanket as AI. We as a company, we prefer to use machine learning, because that's really the backbone of AI, and we kind of steer away from the AI terminology, I guess, because that's our characteristics. But it's data science and machine learning, I guess. But yes, it could be wrapped in AI to a degree. But yeah, we absolutely are integrating this. It's already integrated into Examiner, and that's only going to accelerate with Kontur Orbit. So these tools will become more and more prolific. We already have it for pavement assessment. That will, of course, move into other areas like bridge assessment and utility mapping. So you'll see more and more of this in the months and years to come. Of course, AI is an easy way to wrap it all together. Yes.
And Mike, Pat had an interesting question, which is, and I can assume it's more towards you, but we can certainly answer it from a Kontur perspective also, which is, have you explored pairing this with a mobile LiDAR system to dual collect?
Yes, we definitely have tried that, and we don't believe they're compatible. So a lot of people would disagree, but that's their opinion and not mine. I literally have worked with mobile LiDAR collection, and you can imagine that, say on Vassar Street, there was 2 lanes in each direction. There's parking lanes, and there's also bike lanes that we collected in. So we're doing, 6, 8, 10 passes on a single street with a GPR to get the coverage, because it's directly below the antenna. When you go up and down the street with a LiDAR, you may need 2 passes to collect the data. But if you're collecting it, 8 times, that's absolutely a waste of time collecting it. So we don't feel that the 2 systems work great together. I think there's other sensors that would work great in unison, maybe thermal imaging, maybe ladybug cameras. There's certain other things you could collect that could work good, but there's too much data collected if you're running the LiDAR simultaneously as you're doing full collection with our radar.
Thank you. And from a Kontur perspective, we've got a lot of customers. Obviously, multi-sensor collection is kind of a big thing at the moment, trying to get as much as you can in one pass. Where we don't do any of that specifically at Kontur, but we provide support, whatever our customers need to try and help doing their imaging. Caltrans is a great example that does IR collection, simultaneously. And we do have, we've worked quite a bit with Trimble on different GIS type overall solutions. And so it is a very interesting topic that hopefully is going to get better over time.
Yeah, I think you're right, Ken, because there are certain customers that may work for, but for our type of customers, they were looking for mapping the underground. They didn't have any interest in us getting a point cloud. So we collected photogrammetry for the entire project with a Blue Sky, which was a vendor in New England, and they flew the entire thing. We had a very high quality map for beginning of the project. So for us, that was the logical thing. That's what our client wanted. LiDAR was not a point cloud. That was not their request. So for other people, they may have a different contract, but for us in our environment, our day-to-day business, we don't see that.
Yeah.
Excellent. We just have one last question, and we can probably wrap things up here. And it was from Thomas. A little bit of a switch over also, which is how does accuracy and resolution vary with speed for air-coupled systems?
Well, I think Paul
But air
probably could
coupled,
answer that. Yeah.
yeah. Well. Both sensors, whether it's ground or air launched, is controlled by the operator. So you control the trigger distance. So the distance you take a measurement, you select. So you can choose how often you take a measurement and how deep or the time window you choose. So you choose these in your software, in your collection software called Examiner Collect, which coincidentally I'm going to tell you something about in a second. And that defines your collection speed. So nothing is predetermined for you. You don't have to. Normally, what I do is I decide on how fast or how slow do I need to collect my data depending on the site condition. So what can I do to, what's my traveling speed? What's the environment like? And then I work backwards. So if it's a 30-mile-an-hour street, what's going to be safe for myself or the engineers that are going out there versus the quality of the data that I need to collect? What's the aim of the survey? So if it's pavement, I don't really need to get a huge amount of depth. I don't need to get a huge amount of detail necessarily, right? Now, if the pavement is something like reinforcement and I want detail on that, I want to take more information. I want to get more closer spaced information, for instance. It might slow us down a little bit, right? So you move the density of that three-dimensional data depending on what your needs are, and that gives you an overall speed. So the resolution of your information is controlled by the trigger distance. So you can move that, and you'll see the speed impacted depending on what you're doing. But it's really, really flexible. In fact, in most cases, whether I don't know if you want this in metric or in inches, up to you, or imperial. But let's say typically a 6-inch trigger spacing, you can still drive at 70 miles an hour. So if you think that in mind, if you move some of the parameters around, if you make it even denser than that, you're not losing a lot of speed. So you can balance your survey versus your resolution of what you want to measure versus your collection speed. Yeah. So
Excellent.
it's
And
incredibly dense, yeah, information.
I know we're kind of summarizing and wrapping up, but Mike, did you use an
Yeah.
IMU for your collections at all? I know you've got the Mark IV, which doesn't have one integrated. A Mark VI series does have an integrated IMU, but did you use one separately?
No.
No. Okay. Thank you, Victor. And the very last question we'll take. An Air 3036 effective scan width be customized to reach 3 meters. Technically, Leal, it is slightly less. What is it, Paul? About an inch on either side. So you're slightly less than the full 3 meters on that wide scan width. And then does Examiner Collect support real-time B scans and Google Earth integration? That actually
Yeah,
brings
I
us to a
can.
very interesting announcement that
That's
we're
a
going to
great
have right
question,
now.
and it's a great question, and I'm just going to finish off with letting you know what we've got. So we have a release coming up next week. It is Examiner Collect 1.30. Just so you know, Examiner Collect. This is the application that controls the sensor. Okay, so you know where it lives. It's installed on the sensor. You don't need to install anything else. You run it straight off your laptop connected to the sensor. It's engineered to boost the confidence in the field, so and it integrates a little better with your workflow. So it's been redesigned. And one of the most important parts is that you can plan your survey now. So it's now sitting a little bit ahead of your survey. So instead of going out and collecting your data and then coming back into the office, when you receive your survey request, you can plan in Examiner Specialist, you can take your survey boundaries, you can create your plan and then upload it into your software collection. So you're into your acquisition software, into Examiner Collect, then go to the site and go ahead. And the idea is that you are adding your boundaries, your georeferenced images, and this is going to help optimize your data collection, and you're going to collect exactly what you need. Okay, so much more efficient. And then when you come back into the office or you give the data to somebody to analyze it, it's going to look exactly as you needed it. So very much a quality control and efficiency benefit, right? So the new features that come with this, exactly as your question just pointed out, you have background maps. So you have the same maps as you have in Examiner. So you have satellite imagery, aerial imagery mapping, okay? You can import georeferenced images, things, even if you want to bring in orthomosaics, things from drones, if you want to bring those in as tiles, you can. Shapefiles, all supported. So anything you get that's boundaries, right? You can bring those in. You have live data coverage, so you're seeing where you've driven, what you're collecting, where you're overlapping, for instance. You talked about, can you see the radar coming in? Yes, you can. You can see all three views of the data coming in with the horizontal cut as well. These are new features in addition to the ones that we already have. You also see a GPS signal quality map, so you see the fix. So not only just this where you've been driving, but also you can switch to what a color map that shows you the quality of the fix information that's been coming in. So if you have poor fix somewhere, you can do something. You can see, where the GNSS quality has dropped. Okay. You also have projective paths. So as you're going to turn into maybe you're making a turn, a left or right turn, you can see the heading of where you're heading. So it's a little bit easier for you to follow that projective path. And we have a full API support if you have another system you want to trigger your collection from. You don't necessarily have to use our acquisition software. You could trigger it from somewhere else. Okay, so it's a very flexible product. Plus, it's touchscreen enabled, of course. Okay. And that's it, really. We want to thank everybody for joining us, and of course, DGT and Mike in particular for being one of our customers and for always supplying us with incredible information and project highlights, really, and just giving us information on some of the things that they do, which is really exemplary. So thank you, Mike, for joining us, and for the DGT team for supplying us with information.
Yeah,
Our
thank
next
you for the
webinar.
opportunity.
Yeah,
Appreciate it.
absolutely. It's always great to have you online with us. Our next webinar is going to be Global Trends in Pavement, and that's going to be in September the 18th. So look out for that one. And of course, Examiner Collect, which is coming out next week. And something we haven't got in our slides, which is Examiner Specialist 3.90, which is due in the summer, August time. Thank you very much.
Appreciate it. Thank you, everybody.
Thanks, Mike.
Thanks, guys.
Thanks, Ken.